Hi everyone, let's continue with few more examples on designing of DFA. There is a prerequisite for this video. Before watching this video, you need to understand first how to design DFA for the substring like A, AB or ABB. First watch these videos and then you can come back to this video. Here question is design DFA to accept all the string which consist of symbol of this word and out of that recognizing the string which contains CAT as a substring. First identify the condition. Condition says that there will be all the string consist of the letter CHARIOT. Out of this, if any string contain CAT, that becomes our valid string. Based on that, write down the minimum length string. So minimum length string is CAT. As a substring means what? Before CAT, any symbol may come or may not come, that is 0 or many times. After CAT, any symbol may come or may not come, that is 0 or many times. Now start designing DFA based on this understanding. First state is Q0. First string is CAT. CAT should get accept. It means what? By reading CAT, automata should reach out to final state. So Q0 is the starting state. Q0 reading C. Going to Q1 state, C should not get accepted. Hence it's a non-final. Next symbol is A. CA should not get accepted. Hence Q2 is non-final. Next symbol is T. CAT. That is our main condition, CAT. It should get accepted. Hence transition of this T should go to final state. Q3 as a final state. So CAT getting accepted. Now once we design automata for our main condition, try to make the same automata as a deterministic. Deterministic means what? For each symbol of sigma. Here sigma consists of all the letters of this word. Let me write for your better understanding. All letters means what? There will be C, H, A and remaining 4 letters R, I, O, T. Our sigma consists of all these 7 letters. So deterministic means what? From each state there should be one transition for C, H, A and similar to other symbols. At this moment from Q0 we have only one transition for C. Transition for other symbols are missing. So let's make Q0 deterministic. How to make? Write down Q0 which I want to make deterministic. Ask yourself how to reach to Q0 from starting state. Ask yourself how to reach to final state from Q0. Q0 itself starting state. So starting to Q0, no need to read anything. Q0 to final, what to read? This is a Q0. To reach to final, I want to read CAT. There is a need to read CAT to reach out to final from Q0. At Q0, I am trying to find transition for which symbol? For symbol C, there is a transition. Other than C, I am going to find transition for remaining all symbols. For example, H or A or R, like that remaining symbols. Now our main condition is that R string should contain CAT. Before that, if any symbol is coming or not coming means what? Epsilon. Epsilon contain how many types of symbol? Epsilon is an empty string. It does not contain any symbol. I can say it contains 0 number of H, 0 number of A or any other symbol. So before CAT, if any symbol is coming or not coming. If it is coming, if double H is coming, that is also fine. Triple R is coming, that is also fine. Double O coming, that is also fine. What I mean to say here, before CAT, any symbol may come or may not come, that is epsilon. So when I say may come or may not come, if it is coming, it may come multiple times, so it may come many times. If it is not coming means what? 0 times. So scenario is of 0 or many. For which symbol? For all these symbols, H, A, R, I, O, T. Any type of symbol may come or may not come. But after that CAT has to be read. So it's not going to affect or change our main condition. Hence, as there is a scenario of 0 or many, we'll be writing the self loop at state Q0. For which symbols? For all remaining symbols other than C. So what are those? It's H, A, R, I, O, T. So for all these symbols there is a self loop. Now Q0 is deterministic as the transition for C as well as for remaining all symbols. Now similarly, try to make Q1 as a deterministic. How to make Q1 deterministic? You need to follow the same process. Write down the state which we want to make deterministic. So here Q1 I want to make deterministic. How to reach to Q1 from starting state? By reading C. How to reach to final state from Q1? Same approach, by reading AT. For which symbol you are trying to find transition? Other than A, I am trying to find transition for all symbols. For example, C. Is this valid string? Yes, it contains CAT. If there are two C symbols are coming, still it's valid because it contains CAT as a string. If three C symbols are coming, still it's valid because initially to reach Q1 we have the C. From Q1 to final we have the AT. And at Q1 we are trying to find transition for single C or double C or triple C. If suppose no symbol is coming there, it means what? Starting to Q1 as it is, Q1 to final as it is. Here no symbol is coming means what? Epsilon contain no symbol. Still this string becomes C.epsilon.at. This becomes CAT. Still this becomes valid string. It means what? Q1 is a state trying to find transition for 0 number of C or multiple number of C. 0 or many. For which symbol? Symbol C. At which state? Q1. Hence, if there is a 0 or many scenario, we can give the self loop for symbol C. Now this is for symbol C. Similarly, we can check for another symbols. Let's repeat the same process. What does process says? I want to make Q1 deterministic. So write down the state Q1. How to reach to Q1? By reading C. How to reach to final state from Q1? By reading AT. Write it. Now we have transition for C and transition for A from Q1. What's remaining? Let's take the next possibility, H. Is this valid string? It's not valid string, but at this moment it's not valid. Because why am I saying like this? We are trying to find transition for H, but after H I have written here AT because it's a path from Q1 to final. But after this H, what other symbols may come? We don't know. For example, let me explain you. This is a string CH. At H, I am trying to find transition from Q1. After this, there are many possibilities because we have the 7 symbols. Out of these 7 symbols, there are many more possibilities. And out of these many more possibilities, one of the possibility may that CAT may come. Because what are the other possibilities? For example, there is a possibility of coming RAT or TRA or TAT. Anything may come out of this permutation of 7 symbol. But we need to consider as per our condition, CAT may come. So out of this many possibilities, one of the possibilities that CAT, our substring, required substring may come. And we need to consider the valid possibility because for invalid possibility, our automata will not go to the final state. But for valid possibility, our automata should go to the final state, and that we need to consider. Now, why am I giving so much of explanation? This is a conceptual thing. But in the exam, what you are supposed to do? You can write the same thing in this way. I want to make Q1 deterministic. How to reach to Q1? By reading C. I am trying to find transition for H. How to reach to final? AT. But in between this, there are many possibilities. What's our required possibility? At this moment, this string is not valid, but it can make it valid. If we consider one of the possibility, it may become valid. So how to write it? You can write in this way. This is not valid, but how we can make it valid? By writing CAT. Now why CAT? Because we are looking for our main condition. It may happen that using the existing symbols, you can make it valid. Now in this case, we are looking transition for H. Using H, we cannot achieve the CAT. Hence, I have written completely CAT differently, separately. Now, how to find transition for H here? In this way, you can find it out. I am trying to find transition for symbol H from state Q1. So, I will write it like this. I am trying to find transition for H from state Q1. Transition of H from state Q1 will go to some other state. And that other state will read the CAT, or that other state will have the path for remaining symbol CAT. After reading this CAT, that other state will go to the final state. Why? because CHCAT, this is a valid string. It contains CAT, so this becomes valid, and by reading all the symbol it will go to the final state. Hence transition from Q1 for symbol H will go to some other state, and from that some other state there will be a path for CAT to go to final. So in existing DFA, existing automata, which is the other state that we need to find out? From where? Path for CAT. Check one by one. Is there any path from Q0? Q0 reading C, A and T going to final. We got it. CAT path from Q0. So that other state is nothing but Q0. So transition of H from Q1 will go to the Q0. So I have written here Q0. Now Q1 to Q0 for symbol H. Now similarly I can find out for other symbols, like C is covered, H is covered, A is already covered. See, transition for A, C and H. Next one is R. Again similar scenario. Initially if I write only CR, it's not valid string, but we don't know what will be the next string. Out of these many possibilities, one of the possibility that CAT may come, that we need to consider, and we can read this in this way. Q1 is trying to find transition for symbol R. Transition for symbol R. This transition will go to some other state. From that state there is a path for CAT, and this path will go to the final state. Why? Because this is a valid string CRCAT. This is a valid string. Hence transition from Q1 for symbol R will go to some other state which will have path for CAT going to final. So which is this state? Already we discussed this. That's a Q0. From Q0 there is a path for CAT. Hence transition from Q1 will go to the Q0 for symbol R. And similarly we can write down then same for the I, O and T. So we can write down here H, R, I, O or T. How to read this? Q1 going to Q0 by reading H or R or I or T. You can give the comma or you can give the slash also. Now Q1 become deterministic. Similarly you can make Q2 as deterministic. How to make it? Let's see. I want to make Q2 as deterministic. So how to make it? Write down the state Q2. How to reach to Q2 from starting? Q0 is starting by reading CA. We can make Q2 deterministic. How to reach to final from Q2? By reading T. Now we are trying to find transition for different kind of symbols other than T. From Q2 we have transition for T, but other than T there are 6 symbols for which we need to find transition from Q2. If I take the first symbol C, I am going to find transition for C from the state Q2. At this moment this is not valid string. This is not valid, but it may become valid, because after C what will come? We don't know. After the symbol C, any symbols can come. There are 7 symbols. Permutation of 7 symbols are many more possibilities. Out of that possibility, one of the possibility that we may get the CAT. So let's make it valid. Now how to make it valid? There are different ways. In previous case we have directly written the CAT to make it valid. In this case already we have the C. So do we need to write complete CAT again? No. We have the C, so we can only write here A and T, as we have C here. Now this string becomes valid. So how to read this? Q2 is trying to find transition for C. Q2 is trying to find transition for C. This transition will go to some other state. Which state? The state which will read the symbols AT and will go to final. Why so? Because CRCAT is a valid string. After reading the valid string, automata should go to the final state. Hence transition from Q2 for symbol C will go to some other state, and from that some other state there is a path for the AT. Now we need to find out the state which reading the symbol AT and going to final. Q0 reading AT? No. Q1 reading AT? Yes. Q1 reading A and T going to final. That's what we are looking for. So this other state will be what? Q1. So transition from Q2 will go to Q1 for symbol C. So transition from Q2 will go to Q1 for symbol C. This is the way. Now let's try to find out for other symbols also. So remove this and we can find out transition for other symbols from the C, from the Q2. So write down the Q2 as it is. How to reach to Q2? By reading C. How to reach to final? By reading T. Now from Q2 there is a transition for T as well as for C. What's remaining? Remaining is H. Is this valid string? No. At this moment it's not valid. But we don't know after reading this H, if Q2 is reading H, after reading this H, what will come next? There are 7 symbols. There are many more possibilities of these 7 symbols. Out of this, one of the possibility is valid. And we need to consider that valid possibility. So what's a valid possibility? Check our condition. CAT should contain. At this moment, our string does not contain CAT. So using existing symbol, can we make it as valid? No. So we need to write complete CAT differently. In the previous case, we are using C. That's why I have written AT only. But in this case, H is there. So I need to write complete string CAT as it is. Now how to read this? Q2 is trying to find transition for H. Q2 is trying to find transition for H. This transition will go to some other state. From that state, there is a path for reading CAT and this will go to the state final. So we need to find this other state which will read the CAT, which will have the path for CAT, which will go to the final state. So which is the state reading CAT and going to final? That's a Q0. Q0 reading CAT and going to final. So transition from Q2 for symbol H will go to Q0. This other state is nothing but the Q0 and Q0 will be reading the remaining symbols. So Q2 to Q0 for symbol H. You can connect this like this. But for which symbol? Symbol is H. Similarly, you can try for the next symbol. If suppose there is a initially CAA, it's not valid. Let's make it valid. Out of the many more possibilities, one of the possibilities CAT may come after this A. How to read this? Q2 is trying to find symbol. Q2 is trying to find transition for symbol A going to some other state. From that some other state, there should be path for CAT. So just now we discussed from Q0 there is a path for CAT. So transition for symbol A from Q2 will go to Q0. So I can write here A. Now similarly you can write it for the R also. If you check here CAR, this is not valid. Let's make it valid by writing CAT. Same thing, transition from Q2 for symbol R will go to Q0 from where path for CAT. So I will write similar approach. If we check for the remaining strings, there will be a similar kind of thing. HARIO. 5 symbols, this is the 6 and this is the 7. So Q2 become deterministic. Once we make Q2 deterministic, we need to check for Q3 now. How to make Q3 deterministic? Same approach. Write down the string which you want to make deterministic. So which state I want to make deterministic here? That state is nothing but the Q3. So write it. How to reach to Q3 from starting state? Q0 is starting state. How to reach to Q3? By reading CAT. So I am writing here CAT. At Q3, I am trying to find transition for which symbol? For all symbols. From Q3, at this moment, there is no transition. For all symbols means all these 7 symbols. We are trying to find transition for C. We are trying to find transition for H and remaining all other 7 symbols. Now, how to reach to Q3 by reading CAT? Our main condition is fulfilled here. I want CAT as a substring. After this CAT, if any symbol is coming, maybe once, maybe twice, or maybe multiple times or 100 times, means many symbols may come of type CHARIOT. Any symbol may come multiple times, or it may happen that it won't come single time also, means what, 0 times. Once we read the CAT, any symbol come multiple time, or after reading the CAT, no other symbol will come. It means what, 0 times. Can I say 0 or many? Yes. So after reading CAT, 0 or many symbols may come. 0 or many means what? Self loop. At which state? State Q3. For which symbol? For all these remaining symbols. So remaining symbols are CH, A, R, I and OT. And this becomes our final DFA. As all states are deterministic, this is a deterministic finite automata to accept all the strings where CAT as a substring. In the next few sessions, we will learn the similar kind of question where TOC will be a substring and IOT will be a substring. Thank you for watching.